Hi everyone, nice to meet you here. I want to say one thing. If you want to ask our speaker, I will give you a microphone because we have a video shooting in the corner. And if you want to ask our speaker, please do it in English, okay? Okay, thank you.
Hello, everybody, ladies and gentlemen. My name is Erik. I work for Platform SH, and I'm generally known as Erik Evrard almost everywhere. So I'll start with what I call Erik's first law of code dynamics. And that law actually says that if you have a problem and the longer the route to the solution of that problem is, the longer the logical path, the more likely it is that you will download software that you don't need. There is something which we call a safe zone, and there is something outside, which is the danger zone. And once you get outside, you will be in a position where you will start downloading loads and loads of things. I think we've experienced that. Now, this law is closely related with the second law of Erik's code dynamics, which says that for every second that you wait for a page to load, the likelihood that you will absorb 1,000 calories of Pringles and Coke increases by 1,000%. That's also a very generally known law in coding. So my story starts with developers. Once upon a time, in the beginning, we were all innocent. We were all childs, and we were children with a lot of innocence. And computers were toys. We played with them. They behaved as we wanted to. We coded, did things. There was a direct interaction between input and output. And this were scripted languages. Of course, I'm a bit older than most of you, so I remember that one. But it's generally true for everybody. And in these situations, we feel very much empowered. We can do what we want. And basically, the whole world lies open because you feel this empowerment and this connection with what the steering of the software. And so all these things seemed possible and were possible. However, this story is about how this childhood innocence is going to an end and how it's terminating. But fortunately, this story also is a happy story. It's got a happy ending. So don't worry. So in the beginning again, in the beginning, deploying code is fun. We basically typed code and it executed. We had interpreters. And I still remember that Lisp and programming Lisa and stuff. So what we all did was, everybody has a different journey, and depending on your age, my journey was that this computer magazine called Elector, which was popular in Western Europe. Actually, I bought the Dutch version. And I actually used 8-bit data and 8-bit input. You can see these dip switches to program the thing with a simple processor. It had 265 bytes of memory. And this is then a later version that I built with an Intel processor. You can see I didn't have money to buy printed circuit boards, so I had to solder the wires like this. And then I basically built a hex key keyboard, so I didn't have to use binary input. And as you can see, I really like to solder and put things. I have no idea what I've done there. But it worked. It all worked. And this 265 bytes, as soon as I needed more, I had to build this board, which is 4 kilobytes of RAM. And you can see the innocence. Soldering this thing took me months, I guess. It worked. I mean, it was some wires got loose and I have to resolder them, and then it worked. And I could actually enter my first basic interpreter in that thing, entering it in hex, and later I started using assembler. So we were really, really innocent in our dreams and our inspirations. And then later, of course, I bought this, and then I could finally type it on a computer screen. So that was an enormous improvement. And essentially at the time, deploying codes, as I said, was just typing it in. I didn't even have copies, so it was a matter of retyping it, and sometimes you alter the programs as you retype them. Of course, later we could purchase floppy disks, and we had all these more extensive languages like BASIC. And then something changed. Something took away a little bit of our innocence because we got compilers. compilers, really powerful, but they do take away some of your innocence because they introduce delays, complexities, and dependencies, because you have to link it with libraries and all that. So suddenly you created dependencies. Of course, then at the same time in the 90s, the networks got on board and we've had modems. And instead of typing computer programs from books, actually download things from other computers. And the need of the first clouds were born, as it were. And the cool kids were doing things on bulletin boards and the predecessors of the internet. And then in 1995, I started joining the first internet provider in Europe, EUnet, which was a B2B provider. You probably never heard of them, but we were growing fast. And 1 year later, we got actually styling on board. You see HTML3. Anyway, that is all good and nice. The internet was enabling us to do many things, or everything somewhere else. And then the way we did software changed, because suddenly we started building software for other people that was reused. Apache was a beautiful example. But you can see this, 1.2.b2. We got versions, and suddenly you get a lot of dependencies, more than you had with your compilers for the first time. And then you started downloading things. And I remember downloading Maven for the first time. It was as if I downloaded the whole internet, so many jars. And of course, all these libraries and all these dependencies create problems because they depend on each other. You got chains, and sometimes you couldn't update them, and you wanted to update this library, but it broke the whole chain of dependencies. And sometimes there were so many chains of dependencies, you had circular dependencies, and you ended up with multiple versions of the same software in your code, and even slightly different ones. So what was the problem again? The problem is that we wanted to create stuff. I mean, what was a solution that we tried to make? Well, we all had ambitions. For one, I tried to build the first translation engine. Never worked really, but then 15 years later we had Babelfish. I also thought of building aggregators of websites. I thought of a program, because I'm a physicist, that does physics, like Wolfram Alpha. I was trying to build a learning platform, loads of ideas, a catalog for videos and all that stuff. And so we had all these goals and we wanted to build them. But was that what we were doing? No, of course not. Because if you have a practical problem, like I want a ring widget in my program, then suddenly your real worries was I have to up npm. Oh, but now my XML parser is not working anymore because it depends on a library I don't have. And then, oh, my GitHub two-factor authentication expired. Download PHP Storm because I can't manage all this code anymore. And in the end, you get quickly out of your comfort zone, and what you need, 1,000 calories or because it's getting out of hand. So you're losing slightly and accelerate in a more faster way. This is not really killing your innocence, but it is definitely like Gandalf here in Moria. It is actually weakening you a lot, like the Balrog is doing. Now that's one story. That was developers. Now there's another thing, which we used to call sysadmins. Remember the cool kids who build those networks and BB boards and all that? They could communicate with others without leaving the house, didn't have to get dressed, didn't brush their teeth, basically lived their lives in a very isolated manner. Well, they also evolved, like the developers evolved. The networks got a bit out of hand, as we all know, like a growth of 100 to 1,000 per year in growth in the 90s. And very quickly, this complexity was abstracted by the clouds, by Amazon and Azure and others. And you think, oh, that solves the problem. It looks clean and neat. But underlying, there is actually a lot of tools. They use virtual boxes and Capistrano and Puppet and Chef and Ansible and loads of other stuff. They used all these tools to manage their infrastructure. So that is the end. Not really. Oh yeah, that was. What's the fastest way of putting the fan on your computer? Type Vagrant up for any of you who has actually ever used Vagrant. It's much worse than Adobe Flash, actually. So people in the ops world started to work with things like Docker and consistent volume claims, all these very interesting terms that actually developers don't understand very well. And then on the other hand, developers, they have to use terms also like deployment pipelines and composer and local environments and all that. So this is very different worlds, and the infrastructure guys started building really complex infrastructures that make sense, but that are very, very difficult for developers to understand. And on the other hand, developers, they started building very nice architectures and using all kinds of smart tools to structure their applications. But then what you get is what we call this wall of confusion, a wall of confusion between the devs and the ops, because they speak different languages. They have different concepts. Now, ideally, that's why DevOps has been invented. DevOps, if done right, would solve the problem. However, why would a DevOps person actually try to solve your application problem? Because that's what he's supposed to do. He's supposed to understand how your application is on his very complex infrastructure. And the truth is that most DevOps are not able to do that properly because they really don't have the time to understand all this terminology. And on the other hand, the devs don't have the time and the will and the interest to understand the infrastructure. So you end up with this situation, you know this, the anonymous alcoholics. Hello, my name is Erik. I'm a developer, I do DevOps, and I've been logged in as root for 31 days. Why would you as a developer be logged in as root ever, right? But that's what happens. And in essence, that is the drama that actually is unfolding, and that's the end of our childhood innocence. So the thing is, the problem we had and is actually solved by a very long chain of things and brings us totally out of our comfort zone as a developer. We need a lot of Pringles to solve that because it's a distraction. We shouldn't need that. Now, this was still not the end of this childhood innocence. It looked bad, but it's not the end. But what is the end? I've got a very nice example. Who of you knows this company, Equifax? None of you? Well, if you're in the United States, you may have heard that in the US, credit ratings are really important. For whatever you do, you need a credit rating. You want to buy a house, a car, a phone, prepaid subscription. In Europe, this is getting more and more the case too. Well, Equifax is one of the 3 companies that provides credit ratings of every American. So there are 3 companies. Forget GDPR, forget privacy laws. These guys are authorized to extract whatever information they can get hold of. Anything, everything you buy, everything you earn, everything you do. And they, with a formula, which is secret, they provide you with a credit rating to anybody who pays for it. So they have lots of data. Well, if you look up this company, then you won't see good things. You will see things like breach security, because obviously something happened in 2017. And if your company is equaled with Canada, it must be really, really bad. But what actually happened? Well, what happened in 2017 is a very infamous security issue, CVE 2017 5638. What was this? Well, this was actually a Apache struts issue, meaning that somebody could remotely execute code on your machine because they used a lot of Java. What happened is that the data of 147 million Americans was stolen. Credit card data, their credit rating, loads of stuff, private information, social security numbers. Some breach, an enormous breach. And it took actually a long time before they found that out, months. And then the CEO of Equifax blamed it on one person. Let's call him Gary. Because Gary didn't patch a module. That's what he concluded. He had an audit done by a company, and they said, well, there was a patch for this module, and Gary didn't do that. He should have done that. And so the CEO said, it's his fault. Now, the company lost a lot of value. They lost $40 billion in stock value. That's a lot of money. Again, I'm of the age I remember this series of was called the $6 Million Man. Well, that's a lot more than the $6 Million Man, because in today's money, that would be a $29 million man. So Gary was a $4 billion man, apparently, because he did something and suddenly he created a $4 million gap in the balance of a company. So yeah, I mean, and what did Gary make? Gary was just a programmer in a US company, so it was just a very average salary. What did the CEO who blamed poor Gary earn? Well, he collected 90 million after the ding and after he left. So just puts things into proportion. So obviously he didn't take any blame for that, the CEO. But whose fault was it? Who done it? Who is to blame actually? Was it Gary? Was it his manager not telling Gary what to do time? Like, patch your software, dude. Well, no. My point is that it is because they didn't think of software in the proper way. Software is a function of time. We all know that. There is something called software rot, right? If you have a program running, try it 5 years later, 10 years later, it won't run anymore for some reason. But usually two things happen with software. You build new stuff and you fix the old stuff. You repair broken stuff. Now, the making is easy. That's your own rhythm. You do it yourself. You decide what you do when. And you can also automate stuff and make it better, do better testing, and then it will be more sustainable. But the fixing is something else. That's not on your calendar. That's not on your clock. If a patch like this is necessary, it must be applied within the hour. We all know that. Bots will actually find vulnerabilities in software. And basically, before ending this, because this was bad, I mean that they didn't do this in time, there was actually a very unfortunate ending. The way that Equifax handled this was amazing, in an epic way, an epic failure. They also launched, after a few months, a website. Did you think they launched a site called security.equifax.com to explain the public what happened? Of course not. That would be almost competent. No. What they actually did is they launched a new website, which is called Equifax Security 2017.com. It's a bit dodgy, right? I mean, if you see that name. The thing is, when they build that website, it asked people's social security number, and actually and the purpose was to say to people, your system, your data's been hacked, your data's been stolen. The thing is, they always said yes. So it didn't work. It just collected the social security numbers. And then they tweeted around saying, oh, you can go to this website. The thing is, every time a very big corporation creates a website, some people, some hackers will build a new website that looks like it and isn't the real one, a phishing website. So somebody actually built a website called Security Equifax 2017. And what did Equifax do? By the way, OpenDNS consider that website a phishing site. Yeah, but that's not the worst of it. The worst is that they tweeted that she put in the URL of the real phishing site. So I don't know what happened in the company that's doing so much security stuff. They really messed up totally. They really messed up in every way you could think of. So in the news then later that Equifax has been pointing people to a knockoff phishing site. So again, whose fault was this? Was it really Gary's fault? Was it his manager's fault? No, it's all about snowflakes, because this is what happened. Infrastructure at that point in time was done by hand, and change was a bureaucratic nightmare. You needed to basically send a request form, fill out a form. And if you do that, you obviously create a lot of slowness in the organization. And no large organization is agile enough to do such a thing really quickly. It will always take days or even weeks or months before such patches are applied if you do it the proper way according to their own rules and regulations. So we need to think of this in a different manner. Because in an emergency situation, some will always power through and you will get Equifaxed. And getting Equifaxed, that is bad, because poor Gary Maybe 10 years before, he was a child dreaming of changing the world with his programming, like we all did. And suddenly the blame of a $4 billion loss in value is on his shoulders. I mean, isn't that the biggest disillusion you can have? I mean, nobody would hire him anymore. So at that point in time, you lose your childhood innocence. No more discovery, no more play, no more wonder, no lightness, only darkness, right? And is this the end? Well, no. I mean, obviously, I told you there's a happy ending. And there's actually, nowadays, there are ways of doing this in a better way. I mean, will the guys always win? Will they steal our data? Well, last year, we attended a very interesting conference in Moscow, DevOps Moscow 2018. It was some good speakers, and we have actually used some of their quotes and built a story. One of the most important messages was from Gil Turner, and he said, you should adopt a dev-centric position. What does that mean? Well, that means that you should build and deploy by git push or git merge, and that would trigger the whole process. What process? The whole process, creating the infrastructure, creating all the dependencies, solving all the issues, clearing all caches. All that needs to be done from a git push or from a git workflow. It's very, very essential. Release management must be a functional practice, not just technical. Functional means that, well, we all know that our system and application services have built processes, but they're used ad hoc. Well, they should be standardized. They should be standardized, and every member in the team should apply them in the same manner. Not just a few people or one person, but the whole team. That means every time you do, you have a new build process, a member of the team must execute it. So they must all have access to the same tooling and the same build processes. Always test against real data. Now, this happens not often. Very often, you know what people say? Oh, it worked in staging. I've deployed new software. It doesn't work in production, but it worked in staging. But you know why not? Because your staging is not the same as your production. You will typically have different data for starters, and sometimes even different infrastructure, but data will often be the same. So the technology exists. Ceph allows you to make bit-by-bit clones of your production software databases and file systems in real time. Use it, and then you can actually do a real test in every test environment that is the same as your production. And also, everybody, if you have a deploy and you have a test environment, it should be a URL you can actually test and give you to customers, to your Q&A guys, to your compliance engineer or your security team, whatever. But they must be able to do it that way. And this is the link. Always involve your stakeholders and your management. Your management will be a security guy or a compliance manager. Involve them even in this process. But obviously, you can only do this when you've just done the previous stuff. Have a URL, have a very automated process, and have the same kind of data in production and in staging. And also, and this is very security related, but it's essential, only build code to a read-only system. How often does this not happen? Always, say it again, build your code on a read-only system. And if there is writable volumes for your assets, make sure that no code can run in them. Two worlds, do that. This is violated all the time. Please don't do that. And then finally, we work with containers, we all do. Make sure that your read-only systems are disposable. Don't update a container. Don't manage it. Dispose of it, throw it away, build it again, always build it again. That's actually linked with the first thing. Don't maintain them, replace them. Have your tooling in place to do that. And think immutable, what does it mean? That means infrastructure as code. Your infrastructure to the last detail must be described as code, and that code should be linked with your program code. That is one-to-one. It is very, very important. Now, DevOps, what they try to do is manage all these dependencies, all these things that developers need to set. Well, developers should actually be empowered. Developers still must decide what runtime versions are used. Obviously, you want to decide if I'm running PHP 7.1 or 7.3, which dependencies there are. You want to configure the services you're using. You want to configure some rewrites, redirects, all that, and your dependencies. Because if you don't control that, you will have to bother other people all the time. But you should control more than that. That's enough. You don't need to set many details of the infrastructure, just this as a developer. And I think I'm talking to mostly developers here. And then finally, very important, variables that change, and variables always used somewhere, they must be injected in the run application. This is done outside. Don't put sensitive data, whatever it is, into the configuration file, obviously, because that's a security risk. They must be injected in a secure way in running application. Because if you do that in a configuration file, that's an open door, because that will somehow get hacked or whatever. And deploy and test every Git branch in isolation. Isolation, again, linked with disposable containers. Otherwise, you will keep maintaining them, and then you have risks in that misstep. Now, there's of course some disadvantage. You know, oh yeah, this is another thing. There shouldn't be a difference between how you deploy your services and which frameworks you use. You should be very agnostic, because in essence, the infrastructure shouldn't really matter whether you run PHP or Node.js or even Java or whatever. In essence, these processes are the same, which also benefits you when you ever do hybrid stuff and go decoupled. You will save yourselves a lot of headaches if you approach this in this manner. Automation, that's what we said already, database migrations, automated, and do it during every deploy, so it's not a surprise what happens. Now, as I said, if you don't do updates of containers, you have one disadvantage. You will have some downtime. If you automate this really fast, your downtime should be really short, and should be even so short that you can hold your HTTP requests so that people just see a small slowness in the site and then it's going again. But of course, that's unavoidable if you do it this way. So the final one is the feature toggles. Again, this happens so often. People try to toggle features in their code. Don't do that. Don't do that. This is really, really, really bad. Make sure every feature is a new deploy again, and make sure this happens quickly and you get exact copies, because this is the Balrog that will basically kill your childhood innocence. If you do all these things in a proper way, then you actually saved your childhood innocence. Why? Because you don't get out of this yellow circle. You basically don't get distracted anymore, because you basically automated everything which is actually outside the red dot, which is what you as a developer care about, building a good application. And all this rubbish almost of infrastructure, don't worry about it. You can actually be happy again, and this disappears, and your goal is what you regain. And as a developer, what you really want is just to say, well, I need PHP 7.2, I need 50 gigabytes of disk space, click, and I want Postgres and MySQL, RabbitMQ. Oh, by the way, I also want to make sure that the PSP is solved and they are respecting it, and I clear my cache when I deploy, and everything else runs just, you know, no worries. If you have things like this, then basically your yeah, this is just an illustration. Basically, then the ops and the devs will be happy again. They will both regain their childhood innocence. And we're back to the beginning, which is a much happier time. Thank you. Just before there are any questions, if afterwards people want some patterns of platform, come and see me. I've got a bag full. They are really fun. And questions?
You mentioned injection of environment variables in running application, not in the build process, right?
In the build process.
Oh, in the build process.
Yes, in the build
so
process.
They are,
yeah, typically certificates, passwords, like
so
this.
they are written in the inside application and then deployed to the read-only system, right?
Exactly, yes.
Okay.
So I was basically referring obviously to a solution that Platform SH brings. This is where you do this, and you can basically separate that and inject them. So you can really keep them very safe and don't put them in configuration files, which is what you often see, alas. Any other questions?
Okay, so let me thank our speaker and give out him a special certificate.
Thank you.